Hello everyone, welcome to Basic Electronics Tutorials. In this video, I'm going to take up the second numerical on a bridge rectifier with a capacitor filter. Let me read out the question first. A full wave bridge rectifier supplies a load of 500 ohms in parallel with a capacitor of 600 microfarad. If the AC supply voltage is 200 sin 314t volts, find part 1 of the question, the ripple factor, part 2, the DC load current. If you analyze the question carefully, we are told we have a full bridge rectifier that has an input supply voltage of 200 sin 314t. The load resistance is 500 ohms and the smoothing capacitor value is 600 microfarad. We are asked to find the ripple factor and the DC load current. Let us start with the solution part. Let me quickly write down the given values here. We are told the input voltage is 200 sin 314t. Please note this is in the form of Vm sin omega t. So comparing these two equations for Vs, we find that the maximum or the peak input voltage, which is Vm, equals 200 volt. Also, the value of omega is given as 314. We know that omega is nothing but 2 pi f and this is equal to 314. So, the value of f, which is the input frequency, is 314 divided by 2 pi. Computing this, you will obtain the answer as 49.9746. So, I will take it as 50 hertz. We are also given the value of the load resistance, which is RL and is equal to 500 ohms. And the smoothing capacitor value is given as 600 microfarad. Right, that are the given values. Let us start with part 1 of the question, which is to find the ripple factor. The equation for ripple factor is given by 1 divided by 4 root 3 into FCRL. All of the values of this equation are available. So, let us substitute and find the value of the ripple factor. Computing this, you will obtain the answer for ripple factor as 0.00962. That is the answer for part 1 of the question. Let us go back to the part 2 of the question, which is to find the DC load current. Please note it is denoted by IDC. The equation for DC load current is given by VDC divided by RL. Let me call this as equation 1, where VDC is the DC output load voltage with the capacitive filter. The DC output voltage with the capacitive filter is given by the formula VDC equals Vm minus of IDC divided by 4FC. Let me call this as equation 2. Please note equation 1 is for the DC load current value and it has VDC term in it. However, the equation for VDC, which is given in equation 2, has an IDC term in it. So, the best way to solve these equations would be to simply substitute equation 2 back into equation 1, which will eliminate the VDC term and find IDC directly. So, now I will substitute equation 2 back into equation 1. So, it would be IDC is equals to VDC divided by RL, which is 1 divided by RL into VDC is equation 2. So, I will write the equation to RHS here. Let us now take 1 divided by RL to the LHS. So, the LHS becomes IDC into RL. and the RHS would be Vm minus of IDC divided by 4FC. Now I will take the second term in the RHS of the equation, which involves IDC, into LHS. So the LHS would now be IDC into RL plus IDC divided by 4FC equal to Vm. Let me take IDC common in the LHS here. So it would be IDC multiplied by RL plus 1 divided by 4FC, and the RHS is Vm. Let me now take the coefficient of IDC in the LHS to the denominator of RHS. Therefore, IDC would be Vm divided by RL plus 1 divided by 4FC. Let us now substitute the values for the elements in the RHS here. Vm is 200 volt, RL is 500 ohms plus 1 divided by 4 multiplied by frequency is 50 hertz multiplied by capacitor value is 600 microfarad. Simplifying this, we will have 200 divided by 500 plus 8.333. Simplifying this, we will obtain the value of IDC as 0.3934 amperes. This is the answer for part B of the numerical. Well, that is the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.